Hello everyone. Today we will learn inequalities and system of inequalities in two variables, and then we will see how to graph and how to solve such kind of inequalities. Now, first, just as a recap, last time we learned system of linear inequalities or linear inequalities in one variable. For example, if we have 2y plus less or equal to let's say 1, then this is a linear inequality in one variable. Okay, or if we have x greater or equal to 0, for example, this is an inequality. Now here we have a linear inequality in two variables. So a linear inequality in two variables is written in this form. This is the standard form. So we have x plus by less than c. This is a constant, and b and c are the coefficients of the respective variables, and x and y are variables. And in order to call this a linear inequality in two variables, a and b should be different from 0. Okay, if they are 0, then, or if at least one of them is 0, then it's not linear inequality in two variables anymore. Okay, now if we have a linear inequality in two variables, how can we graph the inequality? For example, let's consider this example. We have 4x minus y greater than 3. Okay, so we want to graph this inequality. Remember, for linear equation in one variable, or linear equation in one variable, we know that the solution, well, I should say in two variables, linear equation in two variables, the solution to the system, to the equation, gives us a straight line. Okay, if we put them all together in the plane, if we plot all of them, then it will give us a straight line. This is the solution to an equation of a straight line. Linear equation in two variables. Now, if we have an inequality in two variables, then how do we graph it? Now, the first step to graph this is we would like to rewrite this one in the related equation, which means, just for now, just to make life easier, change this one to inequality. Okay, now I will write this as 4x minus y equals to 3. Now we know how to solve this, or how to plot this. Let's rewrite this one in slope-intercept form. So this is y equals to 4x minus 3. So as you can see, we have the equation, the related equation, and let's graph this equation now. And before we graph this equation, we have these two things to note. If the inequality is strict, if it is either less than or greater than, then use dashed line, which means dot dot dot, something like this. If it has less or equal to, if it is less or equal to or greater or equal to, if it is not strict, then we use the solid line. Okay. So for this one, as you can see, the inequality is strict. So when I graph this equation, I should use a dashed line. Okay, so let's plot this. For this one, the slope, the y-intercept is -3, which is right here, and the x-intercept will be 3/4. 3/4 is quarter smaller than 1, so should be somewhere in here. Okay, and then I will draw a straight line from here. So now, oops, okay, since this is strict, we have to use dash line. Okay. And now the question is, well, this is the graph of the equation, the relative equation. Relative equation means when we change that inequality to an equal sign, then this is the relative equation to this inequality. So we have the graph for the relative equation. The next is, well, how do we find out which part or which one is the solution to the inequality? So the solution to this inequality, as you can see, this graph, this line divides the plane into two parts. One is this area above it. The other is this area below it, okay, to the right. So what I'm going to do is I will pick one point from anywhere to the left of this, or it could be from the right side. It doesn't matter, from any area from here. But for me, I will pick one from this area, from this side, okay? And then we decide if the point that I pick from this side satisfies the inequality, then this area is the solution. If it doesn't satisfy this, it doesn't satisfy the inequality, I don't have to try from this area, okay? Just pick one point from one side and see if it satisfies. If it satisfies, then that area is the solution. If it doesn't, then the other side, the opposite, the other one is the solution. Now, let's pick, to make it more simple, let's pick this point 0, 0, 0, 0. And then take the inequality. So we have 4x is 0 minus y is 0 greater than 3. 4 times 0 is 0, 0 minus 0 is 0, 0 is greater than 3. Now, this is not true, right? This is not true. Therefore, this point that we pick 0, 0 is the representative to this area, to the left side area, to all of it, okay? Therefore, if this point doesn't satisfy the inequality, every point on this side doesn't satisfy the inequality. Every point, you pick, even this one, you pick somewhere here, it will not satisfy the inequality. And if you pick one point from this side, it will satisfy this inequality. Okay, for example, if we pick here 1, negative 1, then what do we get? Well, this has to be minus negative 1. So we have 4 plus 1 greater than 3 and 5 greater than 3, which is true. Okay, so any point on this side will satisfy this inequality. Now, how do we represent then? How do we represent the solution? Because for a linear equation in two variables, we know the straight line or the graph itself is the solution set to this equation. Okay, but here we have inequality, and we know, or we said, this area on the right side of the line is the solution to the inequality. Therefore, what we do is we shade this area. So I'm gonna shade it. I don't know if this is a good color. Well, let me see. Okay. So here is the area. Okay. All this is the solution to the inequality. Okay. Now the question is, will the line itself be part of the solution? Okay. Is this line part of the solution? And the answer is no, because, and that's why we use the dashed line. Okay. Since this is strict inequality, this line is not part of the solution, but everything to the right, all this shaded area, it goes forever, of course, is a solution to the inequality. Now, let's look at this another example. Let's consider this example, which is hopefully much easier. So here we have 2y less or equal to 6. And as you can see, the inequality is not strict now. So we will use solid line. Now the related equation to this one is, we write this one as 2y equals to 6, simplify it, y equals to 3. And what is this, what type of line do we have for this one, or what is the graph to this equation? Okay, so here we have y equals to 3. If I draw, okay, here we have y and x, and y equals to 3 is this point. Therefore, we put a straight line here. Okay, this is y equals to 3. And now the question is, well, which side is the solution now? Is it the lower side or the upper side? Because this is a horizontal line now. And to answer that question, what we do is we pick a point, let's say from this lower side or from the upper side. Now we will pick from the lower side because this is always easier. You can pick any point, it doesn't matter, but I will pick this 0, 0, 0. So I will try it here. So y is 0, x, we don't need the value. Therefore, 2 times 0 is less or equal to 6. 0 is less or equal to 6. Okay, which is true. Therefore, the solution is this lower side. So we shade this area, and this is the solution to the equation, to the inequality, sorry. Okay, and including the line, because here the inequality is not strict, it's less or equals to, therefore the line is part of the solution. Okay, so this is solution to the inequality. And similarly, if we have a vertical line, we can also draw the solution to the inequality, or the graph of the inequality. For example, if we have x greater or equal to 1, then we can write this one as x equals to 1, and then the graph to this one, let me use a different line, a different color. And so x equals to 1 is this point. So the line becomes a vertical line. Okay. So this is the line. And now the question is, well, which side is the solution to this inequality? And again, as always, we pick one point. For example, in this case, I can pick somewhere on the right side instead of 0, 0. I will pick, let's say, this point, which is 2, 1. Okay. So here, what do we have? If I plug 2, because x is 2 here, 2 is greater or equal to 1, which is true. Therefore, the solution to this inequality is to the right of this line. So I'm gonna use this one now because okay. So this is good enough to show that the right side is the solution. Okay, you don't have to use this kind of color. All right, so this is how we graph the solution of an inequality in 2 variables. Now we will see how to solve a nonlinear inequality in 2 variables. For example, if we have something like this, as you can see, this is not linear, but still we have 2 variables. So how do we solve this kind of linear inequality? And the trick again is the same with what we were doing above. So again, we will rewrite this one. using in the related equation form. So we have x squared plus y plus 1 squared equals to 16. And if you remember, this is an equation to a circle. An equation to a circle with center 0, -1 and radius square root of this one, which is 4. So the equation to this one, the graph to this one will be, oops. Okay. So here, now we need to go back and check if the inequality is strict or not. In this case, it's strict. Now, instead of using a solid line, we will use a dashed line. And we said the center is at 0, -2, -1, which is right here. Okay. And the radius is 4. Therefore, we have 3, 4. Okay. And so it will pass through this one. And from here, it will pass through this. And here. And 4 here. Okay. And now we can connect this. I don't know if I will be able to do that, but anyway, it's just, it doesn't have to be perfect. Okay, not too bad. So here we have the circle. Now the question is whether the solution is the inside part, inside the circle, or outside the circle. Now the two regions are inside and outside. Okay, because we have this kind of shape, and the inside part, the circle divides the plane into two parts. One is the inside, and the other one is the outside part. And in order to test that, we will do the same trick. So we will take a test point. Test point, you can either pick from the inside or outside, it doesn't matter. So pick the easiest, the simplest form, the point. So I will take again 0, 0, and go back to this one and try it. So here we have 0 squared plus 0 plus 1 squared less than 16. So here we have 0, 0 plus 1 is 1, and 1 squared is 1. So we have 1 less than 16, and that's true. Okay. Therefore, since our test point is from the inside, then that means all the points inside the circle satisfy this inequality, which means the solution to this inequality is the inside part. Okay. This is the solution to the inequality. Now the question is, will the line or this line be part of the solution? And the answer to that one is no, because we have the dashed line, and the reason why we put the dashed line is because this inequality is strict, which basically means the line is not part of the solution. Okay, And this is just an example of a nonlinear inequality in two variables. And now we go to solving system of inequalities in two variables. Okay, we started with one inequality in two variables, and then we saw an example of how to solve nonlinear inequality. And then now we look at this solving system of inequalities in two variables. And basically system, when we say system, it means a group of, okay? So in order to have system of equations, we need to have at least two equations or two or more. In order to have a system of inequalities, we need to have two or more inequalities, okay? So in this case, we have two inequalities, which made up this system of inequality, and both of them are inequalities in two variables. So how do we solve this kind of system of inequalities? Now, what we do is we are going to solve each of them individually, which means I will rewrite this in the related form. So that becomes y equals to negative 1/3 x plus 1. And this becomes negative 2x plus y equals to 1. I will rewrite this one. So y equals to 2x plus 1. Now let's find the intersection of these 2 points, two lines. Now how do we solve these two linear equations, or this system of linear equations? If we take this as a system of linear equations, we know how to solve it, and we can use the substitution method because this is easier to use the substitution method in this case. So I will use the substitution method. I will plug this term in place of y in here. So we have 2x plus 1 equals negative 1/3 x plus 1. So we bring this one together. So we have 2x plus 1/3 x equals to 1 cancels the coefficient, they cancel out. So we have 0. So basically here x is 0. Okay. And then if we substitute this one in here, we get y equals to 1. Therefore, the intersection point of these two equations is is 0, 1. Okay, the two lines, they meet at this point, or they intersect at this point. Now, okay, so we have y, we have x, the intersection point. Let me see. So as you can see here, one of them is strict, the other one is not. And this point, it belongs to both of them. Okay, I mean the intersection, both of them, they meet at this point. So this point is not a solution to this inequality, but it is a solution to this inequality. For example, if you try it here, we have 1 less or equal to less than 1, which is not true, okay? Because this is strict. Therefore, this is not solution to the system of linear inequality. It's solution to only one of them. But in order to say this is a solution to both of them, to the system, it has to be solution to both of them. Therefore, the point 0, 0, 1, 0, 1 is right here, no, right here. So instead of putting a point here, I will put a circle open point here, which means they don't intersect here. They don't. This is not a solution to the system. Okay. And now let's draw the graph to the first equation. We have y equals to negative 1/3, 1/3x So it's 0, 1, and 3, 0. So we have this. Okay. Okay, so let's say this is the line. So this is y equals to -1/3x plus 1. And the other one is y equals to 2x plus 1. 2x plus 1, that's I will use different color now. So it will be 0, 1, which is this one, and 1/2, 0. The y-intercept is, the x-intercept is 1/2, 0. So it will be right here. Wait. No, -1/2, sorry. It should be like that. Okay. So it will be something like this. This is y equals to x plus 1. Okay. Now the question is, well, how many regions do we have here? There is one area right here between this line and this line. So let's call this region A. And there is another region between this line and this line. Let's call this region B. This is this area. And then region C, which is this part. And then we have region 4. And that one is, let's call it D. Now the question is, which of all this is the solution to the system? It could be only this one, could be this one, could be this one, or this one. Okay. Now, for this one, for this equation, let's pick one point, anyone from the above or below side. So we can pick the below side, which is we have 0, 0. So if we take test point for this line, 0, 0, and then we have originally the inequality was y less or equal to -0 less or equal to less than -1/3 times 0 plus 1. Okay, so is this true? 0 less than 1. This is not true. So since the test point is from below the line, that means all these two regions, they don't satisfy this inequality, which means this above area is the solution to this inequality. Now I will use this, maybe the black one. So this is the solution to this side is the solution to this inequality. And then how about the second equation? Again, for this one, we can pick the same point, the same test point. The equation was -2x, -2, 0, plus 0, less or equal to 1. So here we have 0, 0, less or equal to 1. And as you can see, this is true. 0 is less than 1. So if we consider this line, the test point is below the line, which means all this part is solution to the system. So first, I will shade all that area. I should use different color. So let me use okay, blue. So this is solution to this inequality. Now let's look at both the solutions and find the intersection. The first one, the shaded part, is the above. So we have starting from here all the way to the right. And the second one is only this to below. And out of all the four regions, which region is shaded with both the inequalities? Well, it's region A, because region A is a solution to this inequality. And again, region A is a solution to this one. We have B, which is solution to only one of them. We have D, which is solution to only one of them. C is not a solution to any of them. Therefore, the one which is solution to both of them is the solution to the system. And one thing that I forgot, I need to make this one dashed line. Okay, it has to be dashed line because the inequality is strict. So we have a dashed line right here. Therefore, I will shade it more. So this is the solution. This is the solution to the system. Okay. So this is how we solve a system of linear equation inequalities in two variables, and it's more or less similar to that of the linear inequality in one variable. But the difference is in one variable, it's we would just use the number line, and we would use just a line like this, let's say to the left, or let's say to the right, or something like this. But this one, we need to find the region which satisfies both the inequalities. Okay, so this is all for today, and see you in the next lecture.